Hey, physicists. So if you remember last time, what we did was we were looking at line density and we took a set of Legos and we were trying to find the total mass of the blocks. So I have a set of Legos here. The first thing we did was we literally can count the number of blocks. So if I say that a 2 by 2 square is one block is one mass, then I can count all these blocks, the 2 by 2 blocks up, and I get 18. The next thing that we did was we set this on a graph that is the line density versus the position. We set a line that went up through that so that if we could picture like this Lego part here would fill in this gap, this Lego part here would fill in this gap, et cetera, all the way up. What that does is it creates a triangle on the top, a rectangle on the bottom, and we can find the area of the underside of that. So your line density times your position, and that's going to give you your total blocks. Lastly, we said there's a more accurate way of doing that is going to be calculus. So remember, the area on a graph is an integral. We set up the equation for that line density to be the line density, the slope of that line up here we calculated to be 1, and then the intercept is going to be 2.5. And so that's going to be our equation for the line density. Then if we take and we split that, line density is the change in mass over the change in position, solve for the change in mass, we can integrate both sides, and then that is a definite integral from 0 to 4. Plug in our line density equation down here into that lambda value, integrate it, and solve, and we get 18 blocks. So that's the beginning of what we were doing. That's finding the total mass. And the reason we do that is because we are going to ultimately be trying to find the center of mass. So the next thing that we're trying to do is we're going to be finding the line density or the center of mass of this object. Now you can conceptually think through it that if my Lego were to look like this, that the center of mass, because of the symmetry, is going to be smack down the middle of the Lego set. It's going to be right here. Now picture this, we're talking about maybe this is a rod, so you can visualize what the rod is, but if you look at the rod this way, it's a little more difficult to think through, like, okay, so I have this rod, and the mass is not evenly distributed. It's distributed in a goofy way. So this just gives us a visual way of looking at it. Now, if I put my Lego back, again, conceptually, I can think, well, don't I have more mass on the right side of this? So my center of mass isn't going to be down the center. It's going to be pushed to the right just a little bit, somewhere over in here. We want to calculate that. So again, what we're going to do is we're going to say that a 2 by 2 block is one mass. And we're going to set a line that goes up through the center of here. So if I picture this as this is a 2 by 2 block, the center of that 2 by 2 block is going to be smack down the middle, as it will be all the way up for that. So I'm going to do that. Now, remember that for center of mass, our center of mass, x center of mass times the total mass, is equal to the sum of all of the individual positions and masses, right? All of the individual positions and masses. So whenever I look at this, I already knew from previously, we talked over here, that the total mass is 18. We're looking for this XCM. And then over here, we're going to add up our individual ones. So I'm going to say you can't quite see it on the thing here, but there are 3 Legos in this first one. So I'm going to say 3 times, and it looks like those are going to be at a half of a distance. So if I set this to be my origin, 0, 0, then I come up to the line, which says that I'm at 3, and I come over to the halfway point, which is a half. Same thing over here. I'm going to come over and have 1, 2, 3, 4 times, and it looks like that's going to be at 1.5, which will be 3 halves. Then I'm going to take over here and 1, 2, 3, 4, 5 times 5 halves, or 2.5. And then over here, I'm going to take 6 times 7 halves, or 3.5. Now, if I throw all of that into my calculator, divide by 18, then I'm going to end up with a center of mass of 2.277 repeating blocks over. So somewhere around 2.277, so about here, is going to be our center of mass. Now, that is good, but it's not exactly the most accurate. So we have this little gap here, we have this little gap over here. We're going to start playing around to make this more accurate. Why don't we try making a block be a 2 by 1 block? So now we're going to say a 2 by 1 block is that. What that does is it splits these in half. So now I'm going to have the center of this is going to be here at 1/4. The center of this is going to be here at 3/4. The center of this is going to be here at 1 1/4 or 5/4. The center of this one will be at 7/4, and you kind of notice how those are increasing. Now, again, if I draw my line here, I'm going to pick this point. I'm going to come up through each of those blocks, and that's going to give me a line that does something like that. And I would say that this guy is not at the top of 3 because 3 is right here. So this is going to be at 2.75. It looks like this one would come all the way up to 3.25. This one is going to come up to 3.75. And you can notice how this is going to get to be a pain in the butt. So I'm going to have XCM as my total mass is equal to the sum of all of the individual ones. So this is going to be XI-MI. Now my total mass, when I go to do that, looks like I'm going to be doing these goofy ones, 2.75 plus 3.25 plus 3.75, 3.75 plus 4.25 plus 4.75 plus 5.25 plus 5.75 plus 6.25. And 6.25 is my last one. So here's my 275, 325, 375, 425, 475, 525, 575, and the last one is at 625. Now, all of that is the left side of this equation. The right side of the equation then is going to be each of these masses times each of these distances that we have. So 2.75 times 1/4, and 3.25 times 3/4, and 3.75 times 5/4, and 4.25 times 7/4, and 4.75 times 9/4, plus 5.25 times 11/4, plus 5.75 times 13/4, and lastly, plus 6.25 times 15/4. Pain in the butt. So what we'll do then is punch all of that into our calculator or into a spreadsheet, which I'll show you here in a second, and punch all of this into it and solve for that center of mass. And when you do that, you should end up with a value that is 2.29167 blocks. Now, notice how the beginning of that is the same. My 2.2s are the same, but now I'm getting more accurate the further down I get for that. So that's going to tell me that it is at 2.2, which is going to be somewhere right around in here, right? 2.29, because this will be 2.5, so 2.2, so sorry, right about there. Now, lastly, we can do this again by integrating. And remember, if we integrate this, we're going to be using the calculus where we say that the x center of mass times the total mass is going to equal the integral of x dm. Now, our dm value, remember from over here, we set is equal to lambda dx. So this is going to be equals the integral of x lambda dx. We said that our lambda is this x plus 2.5. So I'm going to plug that in over here and say the integral of x times x plus 2.5 times dx. It is from 0 to 4, so it's a definite integral. And then this is going to be our total mass. And since we're integrating this, we can literally just say we know the total mass is 18 blocks. So we'll go back to our 2x2 definition there, x center of mass. So this is going to be what? X, the integral of x squared plus 2.5x dx from 0 to 4. So when I integrate that, I'm going to get 1/3 x cubed plus 2.5 over 2x squared from 0 to 4. 1/3 of 4 cubed plus 2.5 times over 2 times 4 squared. That's going to equal 41.3, which is equal to 18 times that center of mass. And whenever you solve for that center of mass, you get a value of 2.29629 blocks. So again, notice how that is becoming even more accurate, 2.29629, and that's where it is. So whenever I look at my block system here, I can say, well, 2 blocks over, which is going to be 1, 2 blocks, and 29 is going to be somewhere in here. So literally what I could do is balance this. So I'm going to take something that I can balance it on, and I can balance it at that point. And notice how it balances on this. Let's see, I don't know if you can see the pink guy there. If I move it this way a little bit, you can see it. So here it's balancing on this pink one, and notice that it's at that 2.29 over. If I go a little further this way, it falls that way. If I go a little further over this way, it falls that way, and that's the center of mass, or the balancing point of that value. So next we'll talk about a couple different ones that we can do the point masses for, but in essence, that is the center of mass, and how you would do it all the different ways. You can either do it by adding up the point masses or by integrating if you have the equation. So in the last video, or last part of this video, we talked about the center of mass, doing both with the Legos, doing it as a point masses and also as a line density. Now we're going to have fun doing just some point masses with some random shapes doing this. So we're going to do the DUPLO one, which is the fairly easy one. I built this Lego shape here. You can see it's the same as the shape here. If you have Legos and you want to build this, then by all means, go ahead and do that. So remember that our center of mass is times the total mass is equal to the summation of all of the individual positions times their masses. So if I, in this particular case, I say that 1 2x1 block is the amount of blocks we're going to look at, then I can look at this and count up the number of 2x1 blocks that I have. Since these are all made they're all 4x2 blocks, then I'm just going to say I have 1, 2, 3, 4, 5, 6 total big blocks times 4 each is going to give me 24 of these 2x1 blocks. So this is going to be my XCM. Now my individual masses, I have to picture this as if I'm going across this row here and say, well, the center of this 2x1 block is going to be a half. The center of this one is going to be 3 halves, 5 halves, 7 halves, and you kind of get the picture of where this is going. So now I'm going to do this across. I have 1 2x1 block there that'll be at 1 half. I have 1 2x1 block that is at 3 halves. I have 1 2x1 block that is at 5 halves. Now I have 2 2x1 blocks that are at 7 halves. When I look at this one, I have 2 2x1 blocks that are at 9 halves. Now when I get to this column here, I have 1, 2, 3, 4, 5, 6 of them that are at 11 halves. And then if I look at the next column, I'm going to have the exact same number, but I've added this one up here. So this is going to be 7 at 13 halves. And then now I'm to this column, which is going to be back to 2 of them at 15 halves. And now I'm going to be 1 of them at 17 halves and 1 of them at 19 halves. And what I want to do is I want to multiply all of those and add all of them up to get a total. When you do that, you should end up with 132 on the right-hand side is equal to the XCM times 24. And if I divide that by 24, I'm going to get a value of 5.5 blocks over. Now, remember that center of mass is the spot where the masses balance out both left and right. So we're looking at the same amount either way, which means that I could literally take and balance this on an object. So what I have here is I have another piece that is just the pink piece sticks up here, and I'm going to balance this on it. And if I come over 1, 2, 3, 4, 5 and a half, then I'm going to be somewhere smack right on the middle of that. And you can see, if I put that there, you can see that that 5.5 is balanced right on the pink part that's there. Or if I kind of lock this down and tip it up, you can see that that's right on that spot there. So that if I put it any farther that way, it tips that way. If I put it too far this way, then it tips that way. And that's how I know that my center of mass is there. Now, I want to take this one and show you. I showed you the math values here of how you would calculate all those. If you remember in the last video, we used Excel also. I showed you how to do it with that. So I can literally take and plug these values in. So here's my 1, my let's see if I can do this with 2 hands here. Here's my 1, my 1, my 1, and then my 2, my 6, 7, 2, 2, 1. Each of these were a half, a 3/2, and so I said that this is the one above plus 1, and that gave me 3/2, and then 5/2, and all the way down. And then remember that the sum of this is going to be my total mass, 24, and the sum of these times each other is going to be my right side, so I can take and divide those, and that's where I get the 5.5 value. So that is the DUPLO one, which is the kind of easy one. In the next one, we're going to do the KFOL, or the kid fan of Legos. Give me a moment to set it up, and then I'll show you that one. Okay, so I'm back. I made this shape that I have here, and I'm going to turn it just so you can kind of see. Up at the top here, I have the missing space there, but all of the rest of this is solid down the bottom part of that, okay? And solid down on the bottom part of this, solid on the bottom, all the way over to the top part of that. So you can see that this is solid all the way across those, except for underneath this one is missing and above this one is missing. And that's how you make it. And you could kind of picture this like that. So again, what we're going to do is we're going to say that one block is really a 2x1 block. Okay, so that's equal to 1 block. And again, if you remember the way we did up above, we said that if I look at this as a 2x1 block, then the center of this is going to be the halfway point, which means this whole right side is going to be by those half values again. So our center of mass, XCM, is going to be our mass total, which will be the sum of the positions times the masses at each of those positions. So I'm going to count up the number of halves that I have. So again, I'm going to have 1, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, 52, 54, 56, 58, 60, 62, 64, 66, 68, 70, 72, 74, 76, 78, 80. So I have 80 total masses that are just the 2x1 blocks are 80. And now I'm going to sum up all of the ones that are in the half. So I'm going to have 2, 4, 6, 8, 10, 12, 14, 16, 18, 18 going down. So I'm going to have 18 times a half. I'm going to have the exact same amount for that second row is going to be 18 times 3 halves. Then for the third row, I have the 2 that are down here at the bottom, but then I have the 1 that's up here. So I'm going to have 3 times 5 halves. The next row is going to be the same, 3 times 5, 7 halves. Then I'm down to only just these 2 in the green, so 2 rows of 2. So I'm going to have 2 and 2, and this will be 9 halves and 11 halves. Then in the next row is going to be this guy. I'm going to have 2, 4, 6, 8, and I'm going to have 2 rows of those. So 8, 8, 13 halves, 15 halves. Then I'm going to have a whole bunch of rows of 2 in a row, right? 1, 2, 3, 4, 5, 6 rows of 2. So 1, 2, 3, 4, 5, 6 rows of 2. And this is going to be 17 halves, 19 halves, 21 halves, 23 halves, 25 halves. Make sure I line these upright. So I'm going to move my 2 down here to 27 halves. Now I have 2 rows of 3. So 3, 3, that'll be 29 halves and 31 halves. Okay, and again, you can punch all of those into your calculator. When you do that, you should end up with a value that is 560 on the right side there. Now, remember, we can use our Excel or our sheets to do this. So this is going to need to be a little bit longer here. I'm going to extend some, insert some rows above here. So this is going to go down. Let's put these values in. I'm going to have 18 and 18 and 3 and 3 and 2 and 2 and 8 and 8. And then it was 1, 2, 3, 4, 5, 6, 7 sets of 2. I'm sorry, 6 sets of 2. So 1, 2, 3, 4, 5, 6. And 2 sets of 3. So there we go. And my last one was 31 halves, which is the 15 and a half that I have there. Then I'm going to take these guys and extend that calculation down. And it looks like I didn't do something correctly because I'm not getting the, oh, I did miscalculate something there. That should be 480. So I'm doing something wrong. My mistake was actually in the Google Sheet. So this value, notice that I am only summing it up to that point. So what I want to do is I want to change it to be where I am going all the way down here to 17. So I want to change this to C17. And then I want to make sure that this is going the whole way down too. It is not. So I'm going to change this to go down to A17. And then I was correct that this is not the right answer. That's actually the answer to the next problem. So this answer is going to be 408. And whenever I take 408 and divide it by 80, then I get a center of mass that is 5.1 blocks over. Here, if I take 5 blocks over, I'm going to have 1, 2, 3, 4, 5.1. So at that point right there, I should be able to take and balance the whole thing at 5.1 on my pink balance, and you can see that that's right about where that is there, if I can get that to balance right there. So that is 1, 2, 3, 4, 5.1 is on top of that pink, and that's where it balances. So that's how you would do the KFOL one. Now we're going to take and do the TFOL one, which is teen fan of Legos, and that's we're just going to rotate this so that now it looks like a huge flipped question mark. Okay, so here we are on the TFOL, which if you remember is teen fan of Lego. And all we did was we rotated the KFOL. So this was our last one that we did, and we found that the center of mass was here at 5, I think it was 5.1. Now we rotate it this way, and I'm just going to play with it. I see there's a base down here. If I stand it up this way, it looks like it stands on that base. So I know that my answer, my center of mass, has to be in one of those columns. So I could literally say 1, 2, 3, 4, 5, 6. It's either in the 7th through the 8, 9, 10, 7 through 10 somewhere. I also noticed when I stand it up that it tips a little bit this way towards the left side of it, which means that there is more mass on this left side. So I know that that's going to be closer to the 7 than it is going to be the 10. So those are just some of the conceptual things that I'm thinking through as I look at that. So remember that the center of mass times the total mass is equal to the sum of all of the individual masses and their positions. If you remember from the teen fan of Lego, we said that the total number of, if we define this to be one block to be 1 2x1 block, that there are 80 of those. So we still have 80 since it's the same as the KFOL one. And then if you remember, I'm also going to say that, well, in this row, this column, then the center of mass of that column is going to be at a half. And the center of mass of the next column is going to be at 1.5 or 3 halves, and so on down. So this would be 1/2, 3 halves, all the way down where I'm just constantly upping that integer by 2 values. So 1, 3, 5, 7, etc. So then I want to count the number of masses that I have at each of those positions. So I look at this first column, and I would say that it's double deep. So I'm going to have 2, 4, 6, 8, and it looks like I have 2 columns of 8 there. So I'm going to have 8 times 1/2, 8 times 3 halves. Now I look at the next one, and I'm going to have 2, 4, 4, right? 1 on top, 1 on bottom, 1 on top, 1 on bottom. So I'm going to have 4. And it looks like I'm going to have 1, 2, 3, 4 rows of those 4 values, 4 rows of the 4. So I'm going to have 4, 4, 4, and 4. So this will be 7 halves, 9 halves, and 11 halves. Then I get to this column, and I'm going to have 2, 4, 6, 8, 10, 12 of those double blocks. And I'll have 2 of those columns in a row like that. So 12 times 13 halves, 12 times 15 halves. Now I get to this column, and it looks like I have 3. So you'll notice here that there's only the bottom. Oops, I just popped it off. There's only the bottom layer of that one, but then this up here has the top 2. So I have 2 sets of 3 in a row. So this would be 3 times 17.5, 3 times 19.5. Then I get to this column, and I have 2, and I have 1, 2, 3, 4, 5, 6 columns of 2 in a row. So I'm going to have 2, 2, 3, 4, 5, 6. So 21 halves, 23 halves, 25 halves, 27 halves, 29 halves, and 31 halves. And finally, I'm down to my last two columns, and you'll notice that there's not a block underneath this part here. So in each of those columns, I'm going to have 2 3s. So I'm going to have a 3 and a 3, a 33 and a half, and a 35 and a half. 35 and a half. And then I'm going to take and I'm going to punch all of those into my calculator and sum all of those. And if you remember from the last video where I put the wrong one on it, you should end up with 560 for that. And then if you divide that 560 by 80, it happens so that it is 7 blocks in. 7 blocks in. Now remember again that we can take and put that into an Excel file. I went ahead and did that ahead of time here. So I have my 8 value. Whoops, I should keep that up for you to see. So I have my 884444, 88444 all the way down. And then notice that this column increases by, so it starts at a half and increases by 1 all the way up. So adding up this column is going to give me my total mass, which is this mass total here. And then this column is taking my x times my m, or mass times position, and adding all of those up to get that 560 value. And then this divides it to get the 7. And so then if you remember from the beginning of this section, didn't we say that it was closer to the 7? And so I could take my pink guy here and balance this. I don't know if I'll be able to show this on the video or not. Balance that right on the 7 there, so you can see it's balanced smack on the middle of that 7, of the 7 value is in there. And then the next one is going to be a little bit more goofy one. It is an adult fan of Lego, and we'll do that in just a second. Okay, so here we go. Last one. If you made it this far, this is the AFOL problem, which is adult fan of Lego. You'll notice that this is set up kind of a goofy shape here. And the only thing I probably need to tell you is that I used one new kind of piece, and that is this one. It is a 6x2 piece instead of a 4x2 piece. I used 2 of them, and they are the 2 pieces that go under this stretch here. So notice that I have the two 6x2 pieces there. You'll notice also that there are parts that are missing. So this one is missing the one on the bottom there, and then it's missing the 2 parts that go there, and then there's one over here that's missing the top one. Otherwise, it would be too deep for all of those. Okay, so now that we have this, I look at this and I say, hey, I'm going to try and set it up like we did on the last one where it balances there, and I notice that it tips over to my left here. So that means if I take my stand, my balancing stand, I should be able to find out where it rests by sticking and balancing it, and it looks like it's going to be right at that spot there. So if I'm trying to see if I can get this so you can see it. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's got to be somewhere right around 13. So I'm just going to jot that number down up here in the corner to say, hey, my guess is that the center of mass is going to be at 13. So again, what we're going to do then, remember that same like fourth verse, same as the first, the center of mass times the total mass has to equal the sum of all of the individual masses times the positions that they're at, So then if I define this to be, again, one 2x1 block, that means that each of these columns is going to be a value. So if I'm looking at this, then I know that I have this column here. Remember that a 2x1 block, so this will be 1, which means the center of mass is going to be halfway on that, or a half. So I'm going to take and do XCM. I'm going to count up all of my total half blocks, which means that, here we go, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, 52, 54, 56, 58, 60, 62, 64, 66, 68, 70, 72, 74, and 76, because remember there's no block on the bottom of that one. And if I check my answer, it looks like that's my total mass is 76 masses, or 76 of these 2x1 blocks. Okay. Now remember the next step is where we're summing all of these. So I'm going to take and look at this and I say, well, I have the first 2 columns are 3. So I'm going to have 3 times 1.5, 3 times 3.5. Then my next one is I'm going to have 2 columns of 2. So 2 times 5.5, 2 times 7.5. Then I'm going to have 2 4. So I'm going to have 2 4 columns, 9.5, 11.5. Then I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 columns in a row that are just 2. So 13.5, 15.5, 17.5, 2, 2, 2, that's 3 of them, 19, 2, 2, 21, 23, 25, 27, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 29, and 31 halves. Phew. Now I'm going to run out of space here on my page. So the next one is going to be these 2 columns, and it looks like they're going to have 2, 4, 6, 8, and 10. So I'm going to have 2 columns of 10, so 33.5, 35.5. Now I'm back to 2 columns of 2, so 2 times 37.5, 2 times 39.5. Oh, I'm so close here. Then I'm going to have 2 columns of 2, 4, so 4 times 41.5 and 4 times 43.5. And then the last 2 are going to be 3 times 45.5. My brain is starting to 3 times 47.5. Then, if I calculate all of that, I should get a total value of 1,000, assuming that I did that correctly. Now, I know I did that correctly because I used the Excel form that we set up that is summing up the total masses, which are all of those individual columns, 3, 3, 2, 2, 4, 4, all the way down. And then here are all of those half positions. And then multiplying the 2 of those gives us the right side of the equation divided by the total mass. And notice that I get a value that is 13.2 or 13.15. That is super, super close to the 13 that we said earlier in the problem. So to summarize all of what we did, remember that center of mass is the idea of where would the mass be if I consolidated all of it into one point. And typically, one of the easy ways you can conceptually think about it is if I had to balance this object, where would it balance so that it didn't fall one way or the other? And that's sort of what we went through with each of these different ones. If I have point masses, then I can use this center of mass times the total mass is the summing of all of the individual positions times their masses. And if I don't have point masses, then we're going to have to do that lambda dm over dx, which gives us an equation so that we can say that this is the integral of x dm and solve by using integration for that. We can integrate to find the total mass, integrate this equation, and we can plug this dm, which would be lambda dx, in for here and solve that value for that. And that, my friends, is center of mass.